All right, so you have your handout. We're only going to go through 4 examples, but it does take some time. So when they give you a point on the terminal side of an angle in standard form, find the exact value of the trig functions. Now, with respect to a unit circle, we have already talked about the fact that sine is x or y and cosine is x, correct? The problem is when I plot this point, when I go over -5 and up to 12, I'm in quadrant 3. Do you agree? That's how you plot the point -5, 12. All right, so I am talking about this angle theta. I need the ratios with respect to that angle. So in order to do this, we're going to have x squared plus y squared equals to r squared. R is always the radius, and radius is always positive. So your ratios, when you are not on a unit circle, okay, these are not on a unit circle. And I'll tell you how I know this in just a second. When you are not on a unit circle, your ratios, y over r, x over r, tangent is still y over x, cosecant, take sine and flip it, so that would be r over y. Secant is cosine's reciprocal, so that would be r over x, and tangent and cotangent are reciprocals. Okay, now a radius cannot be 0. There's no way. If you have a radius that's 0, you do not have a circle. Now, with respect to the location of the terminal side of this angle, I am in quadrant 2. Can you look back at the bottom of your unit circle and tell me which 2 of these 6 functions should be positive in quadrant 2? There's only 2. That information right here on the bottom of your unit circle. In quadrant 2, the only positive terms are sine and cosecant. So I know that this will be positive, I know that this will be positive, and I know that all my other outcomes are going to be negative, simply because the terminal side of the angle goes through this point, and that point is located in quadrant 2. So I have x, I have y. The only thing I'm missing is my radius. So I'm going to do the Pythagorean theorem, and I'm going to put -5 squared plus 12 squared equals to r squared. I'm going to do the math. That's 25 plus 144 equals to r squared. That ends up being 169 equals to r squared. So r is 13. A radius cannot be negative. So if I know that x is -5 and that y is 12, and I now know that my r value is 13, I can plug these 3 numbers in for these ratios and come up with my answers. Thank you, dear. The handout is right here on the card. All right, so y over r, that would be 12 over 13. Y over r, 12 over 13. When I go to do cosine, that's x over r. That's negative 5 over 13. If you can reduce the fractions, reduce the fractions. For tangent, y over x. So I'm going to grab 12 and put that over negative 5. See how when I plug in these numbers, the outcomes are what we kind of said they should be. Sine is positive, cosine is negative, tangent is negative. Okay, so now I'm going to do this the easy way. Cosecant is the reciprocal to sine, so I'm going to take 12 over 13 and I'm going to flip it. So 13 over 12. You can put r over y very easily. Secant is r over x, so that would be 13 over negative 5. Negative outcome, which is what we said we should have. And cotangent is x over y, so that would be negative 5 over 12. So I have all the ratios. Now, I know this is not a unit circle because on a unit circle, the radius is 1. Our radius is not 1 unit. It's 13 units. I don't know if that's 13 inches, 13 centimeters, 13 miles. It's not 1 unit. Okay? So I have to include the radius when I am not on a unit circle. All right. The next example, same thing. First of all, I figure out which quadrant I fall in. When you plot the point -4, -10, if you go over -4 and down to -10, you should be in third quadrant. Do you agree with that? Okay, so I know that x is -4. I know that y is -10. I need my r value. So I'm going to use x squared plus y squared equals 2r squared. So that's -4 squared plus -10 squared equals 2r squared. 16 plus 100 equals to r squared when you square both of those numbers. So 116 equals to r squared. Now, there is a perfect square factor of 116. So I can actually, when I take the square root of it, I can simplify the square root of 116. I don't use the square root of 116 as my radius. So square root of 116 actually simplifies to 4 times 29. Y'all verify that and make sure that's right. And that would give me 2 square roots of 29. So my radius is actually 2 square roots of 29, which means depending on where the radius falls, we may have to rationalize some of these answers. So sine, I'm going to go up here. Sine is always y over r. So I'm going to put -10 over 2 square roots of 29. The 10 and the 2 will reduce, so that's -5 over square root 29, which puts a radical in my denominator. Can't have that radical in my denominator. Do you remember from yesterday how you get rid of the radicals in your denominator? I'm going to multiply by square root 29 over square root 29. That gives me -5 square roots of 29 in the numerator and just 29 in my denominator. It's ugly, but sometimes that's kind of what you get. All right. Cosine is x over r. So that would be negative 4 over 2 square roots of 29. The negative 4 and the 2 reduce. So that gives me negative 2 over square root 29. I cannot have that square root 29 in the bottom. So that becomes negative 2 square roots of 29 over 29. Those are ugly answers, but those are the answers that we are given. Tangent is y over x every time. So I'm going to take negative 10, put it over negative 4. That turns into positive 5 over 2 when you reduce it. So I'm going to grab my cosecant, which is r over y. So I'm going to grab my r, which is 2 square roots of 29 over negative 10. Since the radical is in my numerator, I don't have to move it, but I do need to reduce 2 and 10. So that becomes square root 29 over negative 5. Secant is r over x. So I'm going to grab my radius, which is 2 square roots of 29, and put that over negative 4. Same thing. My radical is already in the top. I don't have to worry about it in the bottom, but I do need to reduce my fraction. So I end up with square root 29 over negative 2. As long as my radical is on top of the fraction, life is good. If it's in the bottom, we got to fix it. You have to rationalize that denominator. And then cotangent is x over y. Cotangent is always x over y. So that would be negative 4 over negative 10, which reduces to positive 2 over 5. A negative divided by negative is a positive. All right. The last two examples that we have are kind of spin-offs of what we just did. So make sure you can still see that and I'm sure you can because you still have your worksheet, what all the ratios for everything is. So with respect to every tangent angle, tangent is always y over x. Well, our tangent is negative 21 over 20. I don't know where to put the negative. Okay? So what I have to do is think about the unit circle and the quadrants. So I'm going to go back and I'm going to look at the bottom part of that unit circle because I have a negative tangent value. So the first thing I'm going to do is I'm going to come up here. Tangent is always positive in the first quadrant, and tangent is always positive in the third quadrant, which means it's negative in second and fourth. Do y'all agree? Okay. So tangent is negative here and here. That's tangent. Now, this says that sine also has to be negative. So out of the two quadrants, we're not looking at quadrant 1, we're not looking at quadrant 3. Out of the two quadrants where tangent is negative, which one is sine negative in? It's either this one or it's this one, but it's not both. So when I go back and look at my table, in second quadrant, sine is positive, but in fourth quadrant, sine and tangent are both negative. So my angle, where'd it go? There it is, falls in this quadrant. And in this quadrant, every x is positive and every y is negative. The reason I need to know that is because I need to know which one of these numbers gets that negative. So with respect to where my angle falls, that would be negative y over positive x. So the negative is going to go with the 21 and the 20 is going to be positive. So that tells me x is 20, y is negative 21, and I need to find the radius in order to answer the rest of these questions. Do I need to go back over that for anybody? All right, so I need to do 20 squared plus 21 squared, and that's going to give me r squared negative 21, I apologize. So I get 400 here, 441 here, and that's equal to r squared. That's 841 equals to r squared. And when you take the square root of that, you should get exactly 29. When you take the square root of 841, you should get exactly 29. So lucky for us, we ended up with no radicals. So now all we have to do are fill in our ratios. The sine ratio is always y over r. So that would be negative 21 over 29. Your cosine ratio is always x over r. So that would be 20 over 29. And I can't reduce either one of these fractions. If you can reduce the fraction, reduce the fraction. Cosecant is r over y. So I'm going to put 29 over negative 21. Secant is r over x. And that's going to give me 29 over 20. Like I said, if you could reduce any fractions, do that, but none of these fractions reduce. And then cotangent is x over y. So I'm going to grab 20 and put it over negative 21. So the hardest part is determining what quadrant you're in so that you can assign the negative to the right value. Okay? So in this particular problem, number 4, the last problem I have for right now, secant, I need the two quadrants where secant is negative. So if I go back up here and I'm looking, secant is negative in the second quadrant and in the third quadrant. So right now, I know that I'm either in second or third. Now, I'm not using a first quadrant or a fourth quadrant. This is the deciding factor out of which one of these I use. This says cotangent is bigger than 0, so that means cotangent is positive. So when I go back and look at second and third, where is cotangent positive? Is it positive in the second quadrant or the third quadrant? Third quadrant. So this is the quadrant we're dealing with. That means my angle terminates somewhere over here. So that means negative x and negative y. Okay? Secant for any angle is always r over x. Do y'all agree? Okay. So that means I have negative square root of 10. That would be negative square root of 10 over 1, but that would be square root of 10 over negative 1. Your top number cannot be negative because it's a radius. So now I know that x is -1. I need to figure out what y is, and they gave me r, square root of 10. So square root 10, are they coming to us? -1 squared, I'm sorry, plus y squared equals to square root 10 squared. So that's 1 plus y squared equals to 10. Subtract your 1, you get 9, and y equals to actually plus minus 3. Now, the reason that y can equal to positive or negative is because depending on which quadrant you're in, some quadrants y is negative and some quadrants y is positive. Well, we're in third quadrant, so my y value has to be negative. So I'm going to use -3 as my y value. Because I'm in third quadrant, every x, every y is negative. Okay? And now I go through the motions. Sine is y over r. So that would be -3 over square roots of 10. That will simplify, and we'll simplify that when we get back from lunch. All right, so we had already found x and y and r. So when we plugged in our values for sine, I do end up with a radical in the denominator, but that gives me -3 square roots of 10 over 10, which I cannot reduce 3 and 10, so I can leave it just like that. Cosine is x over r, so that would be -1 over the square root of 10, which would become negative square root of 10 over 10, and you cannot reduce that. Tangent is y over x, which would be -3 over -1, which is just +3. Cosecant theta is r over y. So that would be square root of 10, and that is over -3. You do not have to rationalize that because the radical is always already in the numerator. And then the last one, cotangent, is x over y. So that would be -1 over -3, which would stay +1/3. Now, the difference in the 4 problems that we just did, our radius is not a 1. Okay, that's the difference. So for the flip side, we did some of these yesterday. I do not remember. Did we do the multiples of 3? Okay, that's what I thought we did. So this says use reference angles and the trig function for the values to find the special right angles. So what we're going to do, where is 330? What quadrant would 330 fall in? Because it is a unit circle angle. Would it be over here somewhere? Okay, that's between 270 and 360. Now, reference angle, that's this little angle right here. So if this angle is 330 degrees, theta prime means reference angle. And reference angles are always positive and acute. Reference angles cannot be negative. even if your angle is negative. So all we're going to do right now is we're going to calculate reference angles, all right? So if you are in quadrant 1, you will take whatever theta is, that will be your reference angle. Because every angle in quadrant 1 is acute, okay? If you're in quadrant 2, you're going to take 180 minus theta. It might even be considered pi minus theta. And that will give you a quadrant 2 reference angle. Now, if you are in quadrant 3, what we're going to do in quadrant 3, when you are in quadrant 3, you're going to take theta and subtract pi, or you're going to take theta and subtract 180. Now, sometimes, unfortunately, these two may have to switch, but I'm relating it back to 180, and I'll show you when we get to 225 in just a second. And then in quadrant 3, we're going to do 360 minus theta, or you might do 2 pi minus the angle. All right, so for number 6, this is actually not quadrant 3, it's quadrant 4. Apologize. If this is 180 degrees and this is 270, this would fall, 225 would fall somewhere between 180 and 270. Do y'all agree? All right. I actually need to know how big this angle is. So what I'm going to do is I'm going to take my 225, since it's bigger than 180, because I need a positive answer. 225 minus 180 is 45 degrees. So my reference angle, remember that's the symbol for reference angle, is 45 degrees. Now, remember, we're not doing this part. We already did that yesterday. We are only calculating reference angles right now. So when I go to sine of 120, this is negative 90, this is negative 180, and negative 120 falls somewhere between them. Do y'all agree? I need to know how big this angle is. Y'all agree with that? So I'm going to take negative 120, and I'm going to subtract negative 180 from it, which gives me positive 60. Positive 60 is acute, and of course it's positive. Reference angles have to be positive acute angles. $135 falls between 90 degrees and 180 degrees. This is the reference angle they're asking you for. So all I have to do is take 180, since I'm in quadrant 2, 180 minus theta. And that gives me 45 degrees, which is a positive acute angle for theta prime. Now, the last ones are a little bit trickier because they are in radian value and not degree value. So when you look on your unit circle, 7 pi over 6 is equal to what degree value? $210. Okay, I know where 210 falls. Do y'all agree? Okay, so 210 is over here. So that's between pi, which is 180, and 3 pi over 2, which is 270. I'm only using the radian language because the problem gave me an angle in radians. So I am going to take I'm going to take 7 pi over 6 and subtract pi from it. When I do that, I get pi over 6. That's my reference angle. All right, negative 5 pi over 4. Where is positive 5 pi over 4? What's the value of 5 pi over 4? 225, which means negative 5 pi over 4 is negative 225. If this is negative 180, this would be negative 270 because that would be negative 90. So negative 225 falls here. My reference angle is still this distance. So negative 180 minus negative 225 becomes negative 180 plus 225. And that means it's a 45-degree angle. This measurement right here is 45 degrees. Now, they gave us a radian. They want us to put it back in radian language, and 45 degrees is the same as pi over 4. You can get that off your unit circle. Now, there is no reference angle here because this is negative 270. Negative 3 pi over 2 is equivalent to negative 270 degrees. So I'm all the way to here. The reason I have no reference angle is because this lands on one of those axes. It's called a quadrantal angle, so there is no reference angle for that. Here, pi over 3, that is equivalent to sine at 60 degrees. When your lands in the first quadrant, that same angle is also your reference angle because you want to know how big this angle is. Notice that I compared every single angle that we drew to the closest x-axis. Even this one. I'm comparing everything to the closest x-axis, and that would be reference angles. All right, so we did two things. We had to come up with our radius when our point was not on our unit circle, And then we had to calculate reference angles. Any questions about either one of those? All right. Well, then I am done.